Good evening, students. Am I audible? Can someone reply whether I'm being audible? Can you guys hear me
Yes,
clearly?
ma'am.
Yeah, thank you. Thank you, Kumar. So, welcome to the lecture on the week 2 of Bioreactor Design and Analysis course. So, we'll go into the some um, multiple choice questions and then followed by a few tutorial problems. I'll start with the first question. So the first question is, determine the correctness or otherwise of the following assertion A and reason R. The assertion here is, engineered Arabidopsis thaliana cells are cultured to high density for the production of polysaccharide gum. And oxygen limitation may occur in the system if there is an increase in the cell concentration over time. And the reason given here is, in a system, oxygen limitation usually occurs when the rate of oxygen supply exceeds the rate of oxygen consumption. There are options given. Option A is both A and R are true, and R is the correct reason for A. Both A and R are true, but R is not the correct reason for A. C, A is true, but R is false. D, A is false, but R is true. E, both A and R are false. Anybody have an idea about the answer for this question? What do you think would be the answer? Any idea? Okay, then I'll tell the answer. So the answer for this question is A is true, but R is false. Okay, now you tell me whether how A is true, but R is false. Any idea? Even if it is wrong, it's fine. We are not going to give marks. Anybody willing to answer? Okay, I'll discuss this then. So, what was the assertion given here? They are telling that there is an cell culture, plant cell culture growing, and it has high cell density. And they are telling that oxygen limitation may occur if the cell concentration increasing over time. So, say for example, in a vessel with impeller, if your concentration is rising, say your cell number or what gram per liter of cells is increasing over time, this is going to get viscous. And obviously, when cells are getting aggregated and more cells are present inside, there is going to be oxygen limitation inside the reactor. And the reason what they have given is oxygen limitation usually occurs when the rate of oxygen supply, which is you give externally with the use of sparger, when the rate of oxygen supply exceeds the rate of oxygen consumption. What is oxygen consumption? The rate at which cells are consuming the oxygen. The statement is true because this should be otherwise. If it is, if the reason was given us in a system, oxygen limitation usually occurs when the rate of oxygen consumption rate exceeds the oxygen of rate of oxygen supply, then this would have been true. A and R are true. But in this, for this question, the answer is A is true. The reason is indeed, if if there is high cell density, oxygen limitation will be present. But R is not true because oxygen limitation usually generally occurs when the rate of oxygen consumption exceeds the rate of oxygen supply. Okay, so the answer for this is A is true, but R is false. So let's go to the next question. So the next question is, there are certain graphs given A, B, and C. Which of the following statement or statements is or are true based on the following figure? There are three figures given. X indicates the biomass and P indicates the product. Okay. So the options given were figure A represents only a non-growth associated metabolite production. Figure B represents a mixed growth associated metabolite production. C, figure C represents a non-growth associated metabolite production. Figure C represents only a growth associated metabolite production. What would be the answer for this question? There may be one or more correct answers to this question. If you can even type in the chat box the options. No need if you are not feeling good about talking. You can just type in the answers in the chat box. Anybody? Anybody wants to answer? So, what do you mean by growth associated, non-growth associated? What does this mean? Have any idea? What is growth association? Growth associated product, non-growth associated product. So, anybody willing to answer? Okay, then I shall answer to this question. So first, let me explain growth associated product and what is non-growth associated product. Growth associated product are produced during your lag phase, from lag phase to log phase, and it is necessary for the growth of your necessary for growth of the cells. And non-growth associated products are generally found or produced during the stationary phase, and these products are not necessarily associated with growth or needed for the growth of the plant cell or any cell, microbial or fungal cell, but it is produced in the presence of stress condition, and when the system reaches the stationary phase it is getting produced. So this is not necessary for growth. So now in picture you are watching a sigmoid curve, which we call um, what a bell-shaped curve. It is showing the growth phase actually. So from this you guys can make out the option for this question. So what does A mean? It is showing the graph. The dotted line is for product and X is for biomass. So what does it say? This means that the product P is growth associated. Is there any an option that growth associated figure A represents non-growth associated? Okay, this option is wrong then. Okay, so this is not the answer. So what does the second B graph represents? It represents that the product is getting produced here in the growth phase also, here in the stationary phase also. So this means it is exhibiting mixed growth pattern. And what does figure C mean? Figure C, you can see it starts its production during the stationary phase. So what are the options you feel? Shifali, you are not audible. I think your mic is on mute. Shifali? Hello. I'm not able to hear you, Shifali. There is a buzzing sound coming, but it is not audible. All others, you guys are able to hear me? Or if there is a network issue or something, you can just type in the answers in the chat box. I will be able to see it. And if you have any doubts in between, also please put it in the chat box. If I'm not being audible or some connection issue is happening, please put it in the chat box so that we can rectify it at the earliest. Okay, so let me continue. So the options which are correct is figure B represents a mixed growth associated metabolite production. This is a right option. And the figure C represents a non-growth associated metabolic production. The option D is not valid because it is a non-growth associated metabolic production, and also option A is not valid because it is a growth associated metabolic production. Okay, so let's move to the next question. Okay, so the question number 3 is dioxic growth represents a phenomenon in which substrates are used in a sequential manner by cultures undergoing multiple lag phases. Is the answer true or false? No idea. True. Yes, right. You're right, Shefali. How it is true? So if you have a two different carbon sources, for example, corn steep liquor and the bagas, and it takes two of them in a sequential manner. So there would be multiple uh, lag phases when the culture will be like experiencing it. So let's go to the next question. A small problematic like problem-based question. So, a genetically engineered strain of bacteria is used to convert a substrate to a product in a batch fermenter. In the exponential phase, the specific growth rate of this bacterial system is given as 0.45 R inverse. Which of the following statement is R or true for this system? So the option A is doubling time is 1.54 R inverse. Option B is doubling time is 0.65 R inverse. Option C is division rate is 0.65 R inverse. And option D is division rate is 1.54 R inverse. What do you think will be the answer? So all the data necessary is given in the question itself. There is only one data necessary. If you remember the formula, you can just crack it in a few minutes. So what is specific growth rate? They have given mu, which is 0.45 hour inverse. So what the options are about doubling time and division rate. What is division rate? What is division rate? Anybody? Or I'll give the formula for doubling time. You can calculate and let me know. So the formula for doubling time is ln 2 divided by mu. So it will be ln 2 divided by 0.45. So what is the answer? Yes,
Ma'am,
Shivali,
its
you are right.
doubling time is 1.54
Yes,
per hour.
exactly. So the answer for this is doubling time is 1.54 hour inverse. What about the division rate? What is meant by division rate? It's somewhere related to your growth with respect to time, right? Now you have calculated the time it takes to double the cells. So nobody is taking the hint. So the formula would be for division rate, it's ln 2 divided by your doubling time, which is 0.693 something divided by your 0.45, which gives around, what is the answer for this? 0. This is not 0.45. Oh, this is 1.54, right? You're doubling time, which would give you 6 log. Should be log 2. So actually division rate is with respect to your rate at which the cell divides with respect to time. Find out the formula next time. Okay. We'll start solving. This is also a smaller sum only. This is about the equation. So let me read the equation. Let me read the question. So Zymomonas mobilis is used for conversion of glucose to ethanol in a batch fermenter under anaerobic conditions. For this system, assume the following conditions. The endogenous metabolism cannot be neglected. Consider the cells to be in exponential phase where the specific growth rate can be approximated to maximum specific growth rate. So which of the following biomass accumulation rate equation is correct for the given batch system? So there are 4 options given. Option A, B, C and D. You are asked which of the following biomass accumulation rate equation is correct for the given batch system. Can anybody tell? It is for batch fermenter under anaerobic conditions. And you are given the condition that endogenous metabolism cannot be neglected. Anybody can answer? So what does endogenous metabolism mean? You can see here where it is given what are these things. The only equations with KD which involves endogenous metabolism is this and this. Obviously, the answer should be anything between these two.
It might be option D because they are saying that endogenous metabolism cannot be neglected, and in option B, it is mu m max minus k times d times t. So it endogenous metabolism minus there is a minus kd into t.
Okay,
So
sorry, there is
it
one
might
more
be D.
thing with KD here, the option A. So, do you guys know how to mass balance the equation? We'll go to that or the derivation part next. So the option would be the right option would be ln of x naught divided by x with respect to kd minus mu max into t. This kd minus mu max came with respect to mass balance. We will be doing in the upcoming next, I think it is in the next few slides. I will be doing the calculation. That time I'll explain about the endogenous metabolism, how it is getting balanced out, and why the sign is negative there. Okay. So I think that question comes in the next two slides. Okay, let's start with some numerical questions. Question number 6 is, during exponential phase in batch culture, the growth rate of a culture is proportional to somebody joining. Oh, so the during exponential phase in batch culture, the growth rate of a culture is proportional to the concentration of cells present. So the rate of the culture is proportional, they are telling, to the concentration of the biomass which is present. When Streptococcus lactis bacteria are cultured in milk, the concentration of cell doubles in 45 minutes. So the doubling time is 45 minutes. If this rate of growth is maintained for 12 hours, what is the final concentration of cells relative to the inoculum level? So how do you calculate this? They're asking if the rate of the cells is doubling, this doubling time is going to be 45 minutes, and the cells are maintaining the rate of growth for another 12 hours at the same rate. What is the final concentration of cells relative to the inoculum level? Let's start by starting with the general mass balance. So it is a batch culture, and this general unsteady state mass balance I will write. Mass in, which is the mass we are giving in as an input, or input minus output, we can tell how much we are taking out, plus rate of generation of cells minus rate of consumption. Consumption is, it is getting consumed, so it is a negative sign. Mass, if it is being taken out, we'll write it as negative. But if you have gone through the lectures, you will know how to do the mass balance. Um, Shifali has said that no, ma'am. What happened, Shifali? For what question you told no, ma'am? Am I audible? Previous one. Okay, okay. So for a batch system is you are putting something in, your cells in, and you're not going to take it out. If you're going to take it out, it is continuous. If you are just going to put your medium, your cells, everything inside and let it grow for a batch time of say 10 days or something. So it is a closed system. You are not going to take anything out. So here the mass in is equal to mass out. It's equal to 0. It would get cancelled out. Okay. So let's assume that there is no loss of cells. So if you do not have this assumption of no loss of cells, then KD comes into picture, the rate of endogenous metabolism. So if I am assuming that there is no cells being lost from the system due to cell lysis, then we can tell this RC is equal to 0. So you were already given the rate RG. So this will become 0, this will become 0, this will become 0. So RG is only term left. So this RG is actually the rate of cell generation or rate of generation of cells. And this is proportional they have given. Uh, what they have given. The growth rate of a culture is proportional to the concentration of cells present. So how do you write RG in terms of your cell concentration? Any idea? It will have a volume term and specific growth rate and your biomass. So mu x into V. So if I do that, let's take it as with respect to volume and biomass only, because the total mass of cells is equal to your volume of the cells or media into cell concentration. So M is equal to V into X. That's why I have replaced my M by M as D into V of X. So, and as it is now that volume is constant, as it is a batch process. So assume V is constant and do the differential equation balance. So we'll take V dx, V will take it out, d and mu x into V. V and V will get cancelled. It will be dx by dt. Sorry. So dx by dt is equal to mu x. Let's take it in one direction. Dx by x is equal to mu into dt. Let's apply the limit. 0 to t. This will give us ln x, right? 1 by x, integrating it becomes ln x equal to mu is the constant and t and a constant k. So we have to take another assumption that at the initial cell concentration, at the initial time t, or at the beginning of the cell growth, or beginning of the exponential growth, x is equal to x naught. Therefore, when t is equal to 0, x we have to apply as x naught. If you apply this here, then what will happen? Ln of x naught equal to mu into 0 plus k. If that is the case, then ln of x naught equal to k. Now you know the value of k. Substitute it in ln x is equal to mu t plus k. So what does that mean? Means ln x equal to mu t plus ln x naught. Instead of k, we are substituting this. So take the ln at the other hand, ln of x minus ln of x naught equal to mu t. So this means we can make ln any ln, it is ln a minus ln b can be written as ln a by b. So I'm writing ln x by x naught equal to mu t. So this is the expression we got. So now going back to the question, what are the data they have given? Now we have formed a relation between your cell concentration and specific growth rate with respect to time. The only data which was given to you was the doubling time and how much time the rate is getting maintained for. So taking doubling time as 45 minutes and also telling that here x naught is the initial concentration of cells, x is the final concentration of cells, and they have told you that at the end of 45 or 45 minutes the cell is doubling. So we can write x as 2 times of x naught, which is 2 times the initial level. So ln of 2 x naught, let's substitute this here, divided by x naught equal to mu into t. Doubling time was given as 45 minutes. So x naught will get cancelled. Ln of 2 is equal to 45 mu, and the mu is equal to ln 2 divided by 45 minutes, which is, what is the answer? 0.693 divided by 45. Zero 0.693. What is the answer? Somebody please calculate and tell 0.693 divided by 45. And give me the units also.
0.0154.
Yes, exactly. Thank you, Komal. It is 0.0154. Unit is, which is important. We are dealing with minutes or hour? I should go back to the question. We have mentioned 45 minutes. So let's take the
Minutes.
unit. Yeah, exactly. So it was here, right? So it is going up. So the doubling time is 45 minutes. So now we have found out what we have found out. We have only found out the mu. But what was the question? The question was, if this rate of growth is maintained for another 12 hours, what is the final concentration of cells relative to the inoculum level? Means with respect to x naught, how much would be x if the cells are dividing at the same rate for 12 hours? Let's calculate that. I don't have space. Well, there is something here. Yeah. So now I know my mu value is 0.0154 minute inverse. So let's apply to our ln x by x naught equal to mu t equation, which is ln x by x naught is equal to 0.0154 into t. We need it in terms of x, that is what is the final concentration. So integrate it or differentiate it. It will become, how it will become? Uh, x by x naught is equal to e power of 0.01.54 into t, and this x is equal to x naught e power of 0.0154 t. So now this is in terms of x. So you know that 12 hours they are telling that it is getting maintained. So let's convert it into minutes. It's equal to 60 into 12, it's around 720 to 720 minutes. So apply this here. Just my calculator. E power of 0.0154 which is around how much it is coming. X is equal to 6.54 into how many decimal places? 6.538 exactly into 10 power of 4 x naught. So, according to your question, if the cells are maintaining the rate at the same pace after 12 hours, the final concentration of biomass would be 6.538 into 10 power of 4 times the initial concentration of the inoculum. That is what is the answer mean. So, do you guys understood? So, first you should start with coming to a relationship between whatever they have given. We came up with a relation for uh, the cell concentration and the rate at which the cells are dividing with respect to time. Then we have applied the given time, which was doubling time as 45 minutes. Then we had found the specific growth rate, after which we have reapplied with the expression we have found, and then made we have kept our x in one side and all other terms in the other side with respect to x naught. So now our answer is after the cells are dividing for another 12 hours, keeping the rate at which it is growing constant, the same level, our final concentration of the biomass would be 6.5, almost 6 point, approximately 6.54 into 10 power of 4 times of the inoculum initially present. Okay, shall we move to the next question? Shall we? Okay, so I shall move to the next question. So this requires actually a graph, but I think that none of you might be having a graph with you or might have an Excel. But I'll try telling you how to solve it. If you have an Excel with you, you can easily plot it and give me the answer. Okay. So the question number 7 is a mouse hybridoma cell line is used to produce monoclonal antibody. Growth in the batch culture is monitored with the following results. So determine the specific growth rate during the growth phase. They have asked you to find only the mu, that too during the growth phase. Growth phase will be this phase. So what you should be doing? You should be plotting a graph with respect to time and cell concentration. So the graph will somewhere look like this. Yeah, it should be looking like this. After 4.5, at 4, yeah, it should be looking like this. So you have to find the slope here. The slope will give you what? It will give you the value of mu, specific growth rate. Anybody is ready to solve the problem? Finding out exactly what would be the slope answer. If you know the from the slope, if you know the specific growth rate, you can easily calculate the doubling time. Okay, I'll give you 5 minutes. Yes, okay, Shfali, I'm waiting for the answers. Take your time, and let me know the answers in the chat box. We have the unit here into 10 power minus 6. Don't forget that when you are calculating. Shifali, you can just let me know the slope value. No need to share the screen. Just show me the slope value, whatever you are getting. When you put a tangent line, the m value, mx plus c, when you put the trend line, there will be an equation showing up in your Excel. If you right click on the data, you will have a add trend line option. There you can just click it and it will show you the equation. So whatever comes as the first coefficient, you can just tell me that value. So it will look like, so if you click, the equation will look y equal to mx plus c. So generally here some value will be there plus some other value will be there. That is called the intercept and this is the slope. Uh, I'm not able to hear you, Shifali.
Am I audible now?
Yeah, it was very feeble voice, but I can hear you.
Okay, ma'am. Actually, I can get the slope. I got the slope, but I cannot find the equation there. I think I've made the graph. I've made the graph, but I think I've put the value in vertical manner. I think it will.
Okay,
I
so the
think
time
the
should be in
horizontal.
the x-axis and the cell concentration, say for example, that is 0.45 into 10 power minus 6 in the y-axis. If you do so, the slope will come around technically around 0.66 to 0.69 because it will be only you have the exponential growth rate is only mu we can take calculate. So in this region, you can form a straight line. For that, we can calculate. Maybe if we try doing it in maybe this is a time constrained time, so that's why. If you take your time to put the graph or try with pen and paper and pencil in graph, try drawing manually, you will be able to see this slope. So how do you do that? Just to plot these values. So it will come like a curve. Try to join 3 points and draw a straight line and take a slope for this, which is say for example um, x2 minus x1 divided by y2 minus y1. If you do, you will get the slope, which is m. So for this question, the slope will be around 0.66 to 0.69 based on how you draw the graph, how the scales are taken. So if that is there, then the slope is equivalent to your specific growth rate. I'm taking it as 0.66 or 0.66. So if I take my doubling time calculation, ln 2 divided by my 0.66 will give me a doubling time of around ln 2 is 0.693. It is around 1.05. So try doing this. All others also try doing it. Find the answer. Okay, find whether the slope I have matches with yours. Okay, great job, Shifali. Who else had tried solving? Anybody else? It's okay. Later on, and after the session ends, also you can try solving it out. Okay. So now let's move to the next question. So this question is about batch culture time. So I think you guys have a similar problem in your assignment too. Is the assignment two has been already submitted or yet to submit? Assignments have been submitted?
No, ma'am. It's yet to submit.
No. Okay, this will be useful for solving the assignments and as well as for your exam preparation. So the Zymomonas mobilis is used to convert glucose to ethanol in a batch fermenter under anaerobic conditions. The yield of biomass from substrate is 0.06 gram per gram. YPX, which is the yield of product with respect to biomass, is 7.7 gram per gram. The maintenance coefficient is 2.2 gram per gram R inverse. The specific rate of product formation due to maintenance is 1.1 R inverse. This is R inverse. The maximum specific growth rate of Zymomonas mobilis is approximately 0.3 R inverse, and 1.5 gram of bacteria is inoculated. 1.5 gram of bacteria are inoculated into 50 liter of medium, which contains 12 gram per liter of glucose. Determine the batch culture times. So you were asked A, determine the batch culture time required to produce 10 gram of biomass. The next question is determine the batch culture time required to achieve 90% substrate conversion. And C, determine the batch culture time required to produce 100 gram of ethanol. So let's start how to solve this problem. So first step in solving a problem is what? Writing down the given conditions. So from the first line, what did we know? They are telling that yield of biomass with respect to substrate, which is YXS is 0.06 gram per gram. The next is YPX, which is with respect to product. It is 7.7 gram per gram. Then they have given the maintenance coefficient, which is MS equal to 2.2 gram per gram hour. And maintenance, next is specific rate of product formation due to maintenance. Yeah, specific product formation is MP is 1.1 hour inverse. And the next is maximum specific growth rate is mu max is around 0.3 hour inverse. And they are telling that 1.5 gram, no, it is not 1.5, sorry, 5 grams. My mistake. It is 5 grams. X naught, they are telling 5 grams they have inoculated in 50 liter media. If you want to put a concentration, 5 gram divided by 50 is equal to 0.1 gram per liter is X naught value. Then they have told that the substrate which is present in this 50 liter of media, substrate S, let's keep it as S, which is glucose, is 12 gram per liter. The substrate concentration, initial substrate concentration is 12 gram per liter. These are the given information we have. What we are asked to find out? We are asked to find out batch culture times at different conditions. So first we will solve batch culture time with respect to produce 10 gram of biomass. So what is the formula for this? Did you guys solve the assignment question? If you guys have solved the assignment question, then this is very easy for you guys to do. Now, okay, I'll start solving. Please, for any assistance in calculating stuff, please respond in the chat box. Okay. So now the question is, we need to produce 10 gram of biomass, but we have already inoculated 5 gram. So how much will be the xt value, which is x concentration at time t, 10 plus 5, which is 15 gram. Okay. So the formula for batch time is x batch time TB is equal to 1 by mu max, let's say A, for question number A. Okay. Mu max ln of xt by x naught. This we have already done this formula, remember? Ln of xt by x naught equal to mu t. This is adapted from there. I have just included mu max to mention mu at the maximum specific growth rate, and t is your batch time. Okay, I have just given the annotation here. So now xt is what? At the end, you want 10 gram of biomass as per the question. You have already inoculated 5 grams. So the total would be xt is equal to 10 plus 5, which is 15 grams at the end. So 15 grams will be in 50 liter media. So 15 gram divided by 50 liter, then the concentration would be 15 by 50 is what? It's around zero point 0.3. So 0.3 gram per liter is your xt. So now let's substitute this xt value here. We know the concentration of x naught already, which is already given. So if you do the calculation, 1 by mu max is what? 0.3. And ln of, this is gram per liter, this is ln, xt is 0.3, this is 0.1, cancel it. This is our inverse. So if you do the math, can somebody solve this for me? 1 divided by 0.3 ln of 0.3 divided by 0.1. 0.3 divided by 0.1 is 3, which is equal to ln 3 is 1.0896. Okay. Hmm. It's coming around 3.66. So let's put it as 3.7, our inverse, the batch time. So to produce a 10 gram of biomass at the end of fermentation, the batch time required is 3.7 hours. Hours. Sorry, our inverse, no, hours. This goes up. Okay. So now what is the second question? The second question is determine Shifali has given 1.59. How Shifali got 1.59? Shifali, where it went wrong?
I'm trying to figure out where I went wrong. Just calculate.
Okay. Okay. So shall we move to the next question, next segment of the problem? Let's go to B. So the question was determine the batch culture time required to produce or achieve 90% substrate conversion. So if 90% substrate is converted means what? Say for example, you are given 100 grams of 100%. The 90% is consumed means if you are giving 100 grams, 90% is converted means then 10 gram is only remaining, right? So the remaining percentage is 10. Let's say the final value is like substrate final is 0.1 times of your S naught because only 10% will remain. This S naught we have known from your uh, given is 12 gram per liter. If that is the case, SF is equal to 0.1 into 12, which is nothing but 1.2 gram per liter. Now you know S naught, which is the initial initial glucose concentration, which is the substrate, and the final substrate concentration is around 1.2 gram per liter. So now this is what ethanol synthesis, right? So ethanol biosynthesis is directly coupled to the energy metabolism, and therefore there are different formulas for different conditions directly linked to the energy metabolism where endogenous metabolism play a picture. So the coefficients with respect to each will get cancelled there. So in case of ethanol production, it is directly linked to the energy metabolism. Therefore, I am taking the following equation. Question is 1 by mu max ln of 1 plus S naught minus SF divided by 1 by Yx plus Ms by mu max into X naught. So here in this equation, there is no, somebody is trying, there is no product is formed which is directly linked to the energy metabolism. So the QP term which comes with the equation will get cancelled. So that's why I have not included the product term here. Okay. So now if you apply all the coefficients, like all the data which we have already calculated everything. Just apply it. 1 plus S naught was 12 minus 1.2 divided by 1 by 0.06. This is MS is 2.2, mu max is 0.3 into 0.1. Now solve this and give me the answer. Take your time, solve this and give me the answer. I have put out all the values necessary. Just calculate it and give me the answer. Anybody solving? I will also solve. Minus 1.2 is 10.8 divided by 1 by 0.06. You are not audible, whoever is talking. What is the answer? I have found. Yes, Sifali, it is around 5.68 hours. Right, you are right. So now the answer for this is 5.68 hours. We can round it off if you want 5.68, 5.7 hours. Thank you for solving it. The next question, there is one more part for this. So now you have to find the batch culture time required to produce 100 gram of ethanol. Here the product term comes into picture. The final product is 100 grams they want. So we have to start writing the equation for it. So if you remember the lectures, if the if QP is coupled to the energy or the product is coupled to energy metabolism, your QP is given as YPX mu plus MP. This QP value would be necessary when you want to calculate it with respect to product. So far we have calculated with respect to biomass, with respect to substrate, and now we are calculating with respect to your product. Sorry. So now applying all the things which we know from the given values, I'm applying it 7.7 this is, and my mu is 0.3, my MP is 1.1. The equation units are here, hour inverse. This is also hour inverse. This is this. So what is the answer for QP? It is 7.7 into 7.7 into 0.3 plus 1.1. It is around 3.41 hour inverse. So now you know the QP value. So initially there is no product present. There was nothing given as initially this much gram of product was present. So P naught is 0 and P at time T is PT is 100 grams. So 100 grams is the mass given. 100 gram is produced with respect to how much liter of your substrate or how much liter of medium they were talking about from the start. It is 50 liter of media. Like how we have calculated our X with respect to medium, we will calculate this also. So for 50 liters. So how much it will be? 2 gram per liter is your product concentration at the end of the fermentation. So for this, the batch time calculation is as follows. Ln of 1 plus mu max x naught into qp pf minus p naught. So if I apply this, is 1 by 0.3 ln of 1 plus 0.3 divided by x naught is how much? 1.2, right? No, x naught is 0.1. 0.1 into my QP is 3.41. My PF final is 2 minus 0. So calculate this and let me know. Let me check. The answer is 3.4. Check whether you have missed somewhere, Shifali. Two point 4 into point 1. Yes, yes, exactly. 3.37, right. Right, Shifali, your answer is right. It's around 3.7. We can assume it as 3.4. What is the unit? Yes, hour. Right, exactly. So that's all for today's class. I hope you were able to clear some problems out. So if you have any doubts, you can message me or mail me in my mail ID. I'll put it in here. You can mail your queries to this mail ID, which I have put here and pinned. If you have any other doubts, you can ask me now. Otherwise, we are done with the session. You guys can take a break. We can meet next week at the same time at 6. Do you guys have any other question? Thank you, Shifali. Thank you, Shifali and Komal for being active in the class. I really appreciate it. Thank you others who are silently solving the problems. I hope you will be able to clear clearly understand the sums. This will be available in the form of recording also. Thank you, Shalini. So if you have no more questions, you can leave the call. Thank you.